Hi, and welcome to my next session of my 3D printer diary. In my introduction, I mentioned that I had already opened my initial order and had been playing with things and tested things. But I also said that I would unassemble and pack it up and revert everything as much to original as possible. So the packages are open, but they are back in their original packages, and here in this box is my Arduino kit. I ordered the Arduino Mega with the ramps 1.4 and the graphic LCD screen. So I am going to go through the contents of the kit. This bubble wrap is the ramps 1.4 board. Okay. And each item individually static wrapped. The ramps board was bubble wrapped and had a protective foam for the pins on the bottom. This pack is the actual Arduino Mega board, which at first I didn't know what it was, but thanks to the contents of this CD that came with it, I read some documentation as well as watched some videos, and I learned that the Arduino board is actually the main board, which actually gets the firmware, and then these are everything on the ramps board is keyed to the pins that run along the outside of the ramps board. In this package is the display board. That is the graphic display, and the cables and adapter board. This is the adapter and two cables to connect to the back of the display board and the adapter board. And the adapter board will eventually sit on top of the ramps 1.4 board. The knob came in the same package side as the cables. We'll visit this board much later. Now, one thing I wasn't able to do was to unseat the heat sinks. The heat sinks came in a just in the box with an adhesive backing as such, so they stuck onto the main chip on the stepper driver, just like a sticker. Now I've already removed the adhesive protective backing and adhered each of the heat sinks on, and as you can see, they all came in a separate static bag, also with foam backings protecting each, and the package came with 5 separate stepper motors. I'm going to put those aside for now. The first thing we're going to work with will be the Mega board. So I'm just putting these back into the packaging. The package also came with a bag of jumpers. The jumpers, I wasn't sure where they were needed when I got it, but through watching a series of videos, I found that there are, like, in between each of the steppers are 3 sets of pins for the jumpers to go onto. We're going to be putting those jumpers onto each of those when the time comes, when I get to that point. For starters, oh, and there was one other thing which I was unable to undo, but the board also came with a pair of connectors, we'll say, and they are for the purpose of plugging into the power on the ramps board for supplying the main power. So yeah, next step, the ramp, the Mega board. It's got a USB port, a USB-B style connector, also known as a printer connector, and a power connector. The instructions say to only use the power connector for testing and when required. But when you're using the USB connector, you don't need to use the power. So we'll connect the USB connector, and you will see that with the green light we have power, and right now it's in the process of booting up, and there it is flashing. Okay, that is exactly what it did when I first plugged it into the USB port. So it is now basically running the default firmware, and using Arduino, which you can download from the site listed at the bottom. I'm sure you know how to download, so I'm not going to go through that tedious, boring process. I just went with the latest Arduino package and installed it. So let's see if I can get it showing up. There we go. There, it's in the process of loading up. Now, my computer isn't the fastest computer, but that's one of the reasons why I'm also using it, to show that we don't need a massive set of power. So back here onto the Arduino, it has now come up, and this is the default when I loaded up Arduino. Actually, yes, I'm gonna keep this so that it fits onto my camera screen a little easier. And now, going through the CD, I read some of the files, and it basically talked about going with blink. Now, as you can see, when I use one of the examples, it opened up a whole separate window, so I'm going to close the one that's in behind. And so we're just going to go through the basics of firmware. I'm going to expand this a little bit so that you can see it a little bit more. Now, as you can see, blink turns an LED on for 1 second, then off for 1 second repeatedly. Now, the board itself is blinking, but you can see that that is far less than 1 second. So we're going to come back up into here. Now, up here at the top, you can see you can verify the code, you can upload the code. Upload means send it to the ramp out of your Mega board. This is to clear it and give a new. This opens a new one, and this saves it. Now, the examples cannot be saved over top, you need to save as. So nice little option there. So what we'll do first to show you the verify, I'm going to back up a little bit so that you can see more. And I click verify, and what the verify does is it basically just does a compile of the sketch and compares it with the board you have connected to make sure that the code is actually viable code and there are no errors in your code. And it also checks to see if it will fit onto the board that you have. And it takes a few minutes. And as you can see, it says sketch uses 930 bytes or 2% of the program storage space. Tells you what the maximum is, and that's based on the board you have connected. So now when you go through the actual upload, it does a verify before it uploads. But then it immediately uploads it. So if I click the upload, it's compiling the sketch, going through the process. So it's going through all the process that it just did. Oh, see, I forgot to do something on here. So it detected, it said, oh, you didn't select the serial port. So it detected it for me. So I'm just going to click OK, COM4, because that is my Mega board. And now, as you can see, the board is right now, has nothing going on. Oh, there it is. It's flashing. Now it says it's still uploading. And this takes some time, but as it's uploading, it's still running the original code. And it's still uploading, and it will finish and give us a message when the upload is finished. It didn't seem to take this long on my other computer. Oh, there it is. Problem uploading board. Okay, this is new. I did not experience this in the past. Let's see what we have. We'll copy the error message. And I'm just going to open Notepad so that I can paste it into Notepad and read exactly what the error message is. As I said, I was going to do this as a diary and run through so that you guys could experience what I experienced. Now we're doing some troubleshooting here. Okay, the programmer says it's not responding. So, we'll just minimize this. That's probably because we didn't select. Ah, there's the issue. Our board is picked the wrong board. We didn't select the correct board. We have a Mega board. And there we are. So now we want to make sure that we select. And now we're going to try and upload again. It'll go through the compiling the sketch. Build options change. See, it's rebuilding it all. Looks like it changed the memory size about what the maximum memory is. Yeah, uses 0% of the sketch. The sketch is basically the program. It's and it's done uploading. So, as you can see, very important to select which board. And you can see the blink, it's still doing the same thing, but it's blinking much slower. Now, I wanted to know a little bit about it, so I went through, and they've actually done a good job of documenting it. So, right here, you can see digital write, so they're writing something to the LED, and basically this is turning it on. And then they're waiting 1,000 milliseconds, and then they're turning it off, and then they're waiting 1,000 milliseconds, and this is a loop. This is basically has very much the structure of C programming. Now there's other programming in behind it that the main program, because if you notice there's no main in this if you are a C programmer. The main program calls this loop. And that is basically what it's doing. So these megas, basically they're running basically a loop, and it's constantly going through. And that is the basics. And one of the things that I had done, I don't have it on this system, but I had actually, in my practicing, I had actually, to make sure that it was doing exactly what I wanted it to, I had made it so that it would blink on and off multiple times, and I actually did this so that I'm going to do this for half a second each, maybe a quarter second each, because what I'm doing here is I'm going to make, so this is on for a quarter second, off for a quarter second, on for a quarter second, off for a quarter second, on for a quarter second, off for a quarter second. And if this is boring, I very much apologize. I just, like I said, I promised I would do on, off. Okay, so that's 3. And then I'm going to do it, for on for 1 second, off for a quarter second, on for a second, off for a quarter second, on for a second, off for a quarter second. And then we're going to go back to $250, so on quarter, off quarter, I don't think I did this right looking at my code. Somewhere I made a mistake. So I'm looking here, just reviewing. On for a quarter, off for a quarter, on for a quarter, off for a quarter. Ah! Here's what I did. There's what I did wrong. I went delayed twice. So see, found my code before I published. There we are. So 1, 2, 3, I'm sorry, on, off, on, off, on. I'm sorry, that's off. So my great apologies. So on, off, on, off. Oh, I went off twice here. Oh, I'm off, off, off. So all my editing there was for naught. I made a big blunder. So let's have a look at what I've got. So I've got on for a quarter, off for a quarter, on for a quarter, off for a quarter. So we have an on, off, on, off. We will copy that with a Control C. We will paste one more in there. Now, what I'm going to do to help organize it better for my own purpose, on, off, on, off, on, off. Okay, that's 3 blinks. I'm going to set that down, and now here is where we're going to turn this on for a full second. Now, to make my life easier, recopy that code, and then paste, paste. So now I should have an on for a second, off for a quarter, on for a second, off for a quarter. And then I will copy the whole thing one more time. Well, copy the original 3. Now, those of you who know Morse code probably see what I've done here. Dot 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 dash 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 dot dot dot. That is SOS. And what I'm going to do here is I'm going to copy this line here just one last time, and we're going to have it delay for an extra second at the end, so that we now know our last delay will delay for a second and a quarter, so that we know our loop is done. And I'm going to upload this. and it's compiling the sketch. Basically, this is going through the verify stage. Make sure that I didn't have any errors in my code. It shouldn't, because all we did was copy each of the lines. Looks like it found everything. Oh, and it's done uploading. And if we now look at the board, we have a dot dot dot, dash dash dash, dot dot dot, and wait, dot dot dot, dash dash dash, dot dot dot. And now our board is calling for help. That's all we're going to do today, because I can see that this video has already gone on for 25 minutes, and I don't think I can post anything for more than 15. So I may need to shorten this video.